Good morning, all. Yeah, hi, Purva. Please share in the group. Purva, share in the group. You're able to see the board? Share in the group. You are able to see the board? Any corrections is required, I think. Yes, okay. So, some more questions. Yeah, some more questions we are going to do on sandwich theorem, squeezy theorem. So, some more here. These I explained here. Sine inverse x expansion. Sine inverse x expansion is x plus 1 by 3 factorial x cube plus 1 square into 3 square by 5 factorial into x power 5 plus 1 square into 3 square into 5 square by 7 factorial into x power 7 plus so and so. This is sine inverse x expansion by using the Taylor series. Yesterday I explained the Taylor series. That sec inverse x expansion, that is 1 plus x square by 2 factorial plus 5x power 4 by 4 factorial plus 61 x power 6 by 6 factorial plus so and so. Next, tan inverse x. Tan inverse x is x minus x cube by 3 factorial 3 plus x power 5 by 5 minus x power 7 by 7 plus so and so. So these are the remain. Yesterday I did not written about these three. These are the remain expansions: sine inverse x, sec inverse x, tan inverse x. Sine inverse x and tan inverse x mostly used. So this is important. And even though you can do by L'Hospital rule also, questions can be solved by L'Hospital rule. But these two things are important: tan inverse x and sine inverse x. So these expansions, you remember it. Okay, now we will do the problems. Okay, some more examples we will do now. Okay, please note down. These are these are, you have the remain examples. Yeah, Sarth Bohi, hello. Anush, yes. Ranjit, yes. Pooja, hi. Yes. Viraj, hi, good morning. Aditya, hi. Chetan, yeah, shared. Okay, now here sine inverse x expansion is that. Actually, yesterday I explained you about Taylor series, right? Taylor series on Saturday I explained about Taylor series and their expansions. We have solved some questions also. So these are rarely used. These three are not much useful. Rarely used, these are three expansions. So this is also I wrote. Rarely we use, these are rare. Mainly, which I explained on Saturday, that only we use most. So that's why I explained on Saturday that are most important expansions. And these three are rarely used expansions. Okay, these three are rarely used expansions. So here why I am going to explain is, you know that limit extending to 0 sine inverse x by x is how much? 1. This is I explained, right? Limit extend. Why I am giving these two is, reason is this one only. Limit extending to 0 tan x by x. You have learned it, right? This is all. Tan inverse x by x is 1. X by tan inverse x is also 1. Trigonometric, these are trigonometric limits. So limit extending to 0 x by sine inverse x. This is also 1. And the limit extending to 0 x by tan inverse x. This is also 1. Okay, these are 1. 1, 1, 1, 1 you are getting. Okay, these are 1. Now, how you are getting means, you just substitute this one, you will get directly. Means here, limit x extending to 0. If I go for sine inverse I have denominator x is there, so I have to take up to x only. So x by x, so cancel, 1 is the answer. right? So like tan inverse also, if I take here limit extending to 0, tan inverse first is x you are getting, x by x, so this is cancel 1. So tan inverse x by x is 1, sin inverse x by x is also 1. You want to take this whole you can take, but if you substitute 0, this all becomes zeros. So 1 is the answer, 1 plus 0, 0 plus 0, 0, that is 1 only. So these are the remain expansions. Okay, now let's see some more questions on sandwich theorem. On Saturday we have done some problems on sandwich theorem. Now we'll do more problems on sandwich theorem, then we'll start trigonometric, some more questions on trigonometric functions. Okay, then tomorrow, after this, we'll start the another very, very important class, infinity, 1 upon infinity, that other indeterminate forms we are going to solve it. Okay, now the question is, this is the question. The question is evaluate limit extending to 0 e power x minus e power minus x minus 2x upon x cube. Evaluate limit extending to 0. Yeah, this is you have. Limit extending to 0, you have this one. Evaluate limit extending to 0 e power x minus x minus 2x upon x cube. So this is can be solved in two methods. One method is if I substitute 0 in this, e power 0 minus e power 0 minus 2 into 0. This is 0 by 0 form. When you get 0 by 0 form, okay, when you get 0 by 0 form, you have to use L'Hopital rule. L'Hopital rule. Okay, L'Hopital rule you can use. So this problem can be solved using L'Hopital rule. Even you can use the expansion also. Even you can use the expansion or L'Hopital rule. First I will do L'Hopital rule, so you will understand. Limit extending to 0. You know e power x differentiation is e power x. And e power x differentiation is e power x. Minus x differentiation is minus 1. Okay, see here e power minus x differentiation of e power minus x is e power minus x into differentiation of minus x is 1. So minus e power minus x. Differentiation of 2x is 2. Differentiation of x cube is 3x square. So now if this is I get as limit extending to 0, I get here e power x plus e power minus x minus 2 by 3x square. See that here in this case what you observe carefully, if I again substitute limit, I get again 0 by 0 form. I will get again 0 by 0 form. So I have to apply L'Hopital rule again twice. I have to apply again till. So if I apply limit extending to 0 L'Hopital rule, means L'Hopital means what is the rule? L'Hopital rule means we have to differentiate numerator, we have to differentiate denominator separate, and we should substitute the limit. So e power x differentiation is e power x, e power minus x differentiation is minus e power x. This is I will get minus 1 and minus 2, and this differentiation is 6x. So what I get here, limit, I get as limit extending to 0, I get here e power x minus e power minus x minus 2 upon, I will get here 6x. If I substitute again limit extending to 0, again I will get 0 by 0 form. Again I will get 0 by 0 form. So again I have to differentiate. So what I do here, limit extending to 0, e power x differentiation is e power x, e power minus x differentiation minus e power x, so plus e power minus x, differentiation of 2 is 0, differentiation of 6x is 6. Differentiation of 6x is 6. Now you substitute the limit here, e power 0 plus e power minus 0 divided by 6. That is 1 plus 1 by 6. 2 by 6. That is 1 by 3 is the answer. So this we have done by using the L'Hopital rule. But this can be solved using the expansions also. Now I will explain expansions, how to do expansion. This is we did L'Hopital rule. Did you understand? So we have done with L'Hopital rule this. Now we are going to, I am going to explain you. Hello, Atar, Tejaswini, yeah. So I explained by using L'Hopital rule. Now I will explain this one using the expansion. Is it okay? Did you understand this? Did you understand? Give me reply, quick reply. Understood. Yeah, Pooja. Now let us see. Now what I do. Now I'll explain expansions using expansion. What is the e power x expansion? That's what I am going to use it. So see, most of the time expansion will work out, otherwise L'Hopital rule work out. Some cases both will work out. Okay. So now here e power x expansion is what? What is e power x expansion? 1 plus x by 1 factorial plus x square by 2 factorial plus x cube by 3 factorial plus so and so, correct? 1 by 1 plus x by 1 factorial plus x square by 2 factorial plus x cube by 3 factorial plus so and so. Now this is e power x. E power minus x means what? Wherever x is there we have to substitute minus. So 1 plus minus x by 1 factorial plus minus x whole square by 2 factorial plus minus x whole cube by 3 factorial plus so and so I'll get. It means e power minus x expansion is what? 1 minus x plus x square by 2 factorial minus x cube by 3 factorial I'll get. Now denominator has x cube, so I can substitute till x cube this expansion. So I can write as limit extending to 0 e power x expansion. So this is goes on like infinity. So now e power x expansion is what? E power x is 1 plus x by 1 factorial plus x square by 2 factorial plus x cube by 3 factorial plus so and so infinity. But I know it is x cube, so I write till x cube only. Minus e power this one 1 minus x plus x square by 2 factorial minus x cube by 3 factorial minus x cube by 3 factorial I can write. So this is what is e power x and e power minus x. I wrote divided by x cube. Now you can expand, open this. What I get here, limit extending to 0. I get 1 plus x square by 2 factorial plus x cube by 3 factorial minus 1 plus x. Am I right? Minus x square by 2 factorial plus x cube by 3 factorial. I think, yeah, then divided by x cube. This plus 1 and this minus 1 cancel out. X square by 2 factor, x square by 2 factor cancel out. Here I get 2x, right? I get what here? E power x expansion is what? E power x is equal to 1 plus x by 1 factorial plus x square by 2 factorial plus x cube by 3 factor. E power minus x will be 1 minus x by 1 factorial plus x square by 2 factorial minus x cube by 3 factorial. Okay, so minus 1 plus 1, yeah. So what I get here, limit extending to 0, I'm going to get x plus x 2x plus x cube if I take common 1 by 3 factorial plus 1 by 3 factorial divide by x cube I'll get. Okay, I think I wrote anywhere mistake. Yeah, you have minus 2x. No, I forgot. Minus 2x. Yeah, that's what I am thinking. Here you have minus 2x. I forgot this. Okay. You have minus 2x also here. Minus 2x. So I wrote minus 2x here. I wrote here minus 2x. So there also, here also I'll get minus 2x. Okay. Here also minus 2x. See what I have done here. E power x expansion, e power minus x expansion, minus 2x by x cube I kept. Then I open the bracket, it is cancelled out. Then I x plus x 2x, 2x plus 2x minus 2x cancel out. Limit extending to 0, what I get here, x cube cancel out. 1 by 3 factorial means 6. 1 by 3 factorial means 6. So the answer is 2 by 6, that is equal to 1 by 3. So you got 1 by 3. See, both cases you got 1 by 3. So you can do the same question using expansions, using L'Hopital rule. That's what I want to tell you. Did you understand? Understood? Did you understood? Understood everybody? Yes, understood. Now let's move on to the next question. So these are expansions. Okay, yesterday or Saturday lecture you have to see, you have to watch, then only you will understand, because Saturday lecture was the main lecture. Okay, today also it is a main lecture, but I am explaining some extra questions today. Saturday the questions are very important questions they are. Today lecture's questions also important. Don't worry, don't think like that. The next question. Yeah, limit extending to 0, e power x cube minus 1 minus x cube divided by sine power 6 2x. So this is the question we have, and this is also can be done in 2-3 ways. Like L'Hopital rule you can do, but power 6 is there, so you have to keep on doing, so it will take more time. Like here you have to apply 4 to 5 times, so I don't think this is applicable here. So simply you go for expansion. So e power x expansion. What is e power? Something is there, e power something is there, e power anything is there, something you have, e power something you have, then 1 plus something by 1 factorial plus something by 2 factorial plus something by 3 factorial plus so and so. Like if you have x, you get here x, you get here x square, you get here x cube, like this. Correct? So here e power x cube will be, if I multiply, you know that limit extending to 0, sin x by x is equal to 1. Limit extending to 0, sin x by x is 1. Same way, limit extending to 0, sin 2x by 2x also 1, because if x is tending to 0, 2x also tending to 0. If x is tending to 0, 2x. So I can multiply and divide by this. So this whole part, limit if I approach, this is 1, it will become 1. So what I get here, limit extending to 0, this denominator will change. E power x cube minus rule. Here I require denominator x power 6. So I can go till x power 6 only. No need to go for another term. So here, according to that, e power x cube I can take 6 till 6. So what I write here, limit extending to 0, e power x cube I can write as 1 plus x cube by 1 factorial plus x power 6 by 2 factorial minus 1 minus x cube divided by 2 power 6, means 2 power 5 you know 32, 2 power 6 is 64. 64 into x power 6. Now this plus 1, this minus 1. See here, if I open the bracket, this plus 1 minus 1 cancel. This x cube by 1 factorial means x cube. This x cube cancel. So limit extending to 0, what I am going to get here, x power 6 by 2 factorial. Okay, I can write as x power 6 by 2 factorial into 64 x power 6. So x power 6 cancel out. So what I am getting, 1 by 128. 1 by 128 is the answer. 1 by 128 is the answer. Did you understand? 2 power minus 7. Why 2 power minus 7? Okay, answer is 2 power minus 7. Okay, fine. So did you understand this answer? 2 power minus 1. Yeah. 1 by 28. 128 is the answer. Okay, 2 power minus 7 also you can write. No problem. So this is the way. Did you understand all? Others you have understood? Understood. Yes, understood. Yeah. So likewise we can do it. Now I will explain most important question, which is Frequently asked in JEE means, and even sometimes in advance, frequently asked questions. So this is most important question which I am going to explain now. Note down. So it is most important question. Okay. I'm going to explain very important question, most important question. So write down, if limit extending to 0, 4 plus sine 2x, this is a previous year question only, a sine x plus b cos x divided by x square, if limit extending to 0, f of x exists and finite find a and b and limit. Find a and b and limit. This is the most important question. These model questions asked in JEE. So this is the most important question. I repeat again. F of x is equal to limit extending to 0, f 4 plus sine 2x plus a sine x plus b cos x divided by x square, if limit extending to 0, f of x exists. Find the finite and finite, exist and finite. Find a and b and limit. So for this, what is required? Sin x expansion required. What is sin x expansion? Sin x is equal to what? X minus x cube by 3 factorial plus x power 5 by 5 factorial. So and so infinity. This is important. Now I am going to use this here. Cos x, what is cos x? Yeah, cos x also important, right? Cos x, what is cos x expansion? Cos x expansion also important. Cos x, yesterday I gave, no? 1 second. Cos x expansion is 1 minus x square by 2 factorial, x power 4 by 4 factorial, so and so. Okay. So I know here, these are the two expansions are required for solving this question. So divide by x square, you have sine 2x, and these are cos x. So these two expansions I need to use to solve this question, and this is most important question. Make it star for this. Make it star for this. It's most important question. Okay, he's saying that limit extending to 0, 4 plus sine 2x plus a sine x plus b cos x divided by x square, and if limit exists and it is finite, find a value, b value and limit value is saying. Now look at here carefully. So I will substitute limit extending to 0, 4 plus sine x. What is the sine x formula? If sine x is there, I'll get x. Sine 2x is there, I'll get 2x. So I'll get here 2x. 2x minus 2x whole cube. 2x whole cube divided by 3 factorial. See, denominator is x square only. So till x square is sufficient. No need to go more. Okay. So this is not required to go more. Okay. Plus a into. What is sin x? Sin x is x minus x cube by 3 factorial. So and so. Okay. It goes on. Right. Next plus b into cos. Cos is what? 1 minus x square by 2 factorial, so and so. But we require till x square only, right? We require till x square, so there is not required of this also, isn't right? Right? So till x square we required. So limit extending to 0. Now constant terms write down. Constant, what you have, you write down that. I think I wrote any mistake. It's 4. Okay, 2x. I can take x is common, right? I can take here x common. No need. Yeah, constant terms you write. Constant is here 4 and here b. Constant, what are constant here? Here 4 I'll get. Here x is there, x cube is there, x is there, x cube is there, x square is there. Here b. So constant is here 4 and b. So I can write as 4 plus b is the constant. Now write down x coefficients. So I am writing x coefficient. Here x coefficient is 2. Here x coefficient is ax. If I multiply, I get ax. Here x coefficient is not there, so no need to write. Okay, I can write here. Yeah. So I can write here what here? Here I can write 2, here I can write a, and totally x common. Now x square coefficients. Now tell me x square. Here x square not there, here x square not there, here x square not there, here x square is there. So what I get here? Minus b by 2 factorial into x square divided by what here? X square. See, x cube terms not required here, because x cube terms will go into 0. It will make into 0. So x cube terms are not required. Correct? I wrote any mistake or what? It is x square or x cube? चलो अभी x square से solve कर रहे हैं, ठीक है? So we are taking x square and solving. Okay, however it may be. So x square is there, till x square I'll write. Now you know that in the previous questions I explained, when x square is there, this will be giving the limit value. Rest all you are going to get zeros. Means this is 0, this is 0, like this it is going to 0. So what is I am going to get here? Here I am going to get 0. That is 2 plus a equal to 0. So a equal to how much? Minus 2. A is equal to how much? Minus 2. Because these all the things are going to become 0. Or cancel. These all the things are going to be cancelled. Only this square will be left. In the previous questions if you see. And here 4 plus b is equal to 0. It means b value is how much? Minus 4. So a value minus 2, b value minus 4. Now if I see these two compare, that will give the limit value. That will give limit. The coefficient of x square will give you limit value. So limit L is equal to what? Minus b by 2 factorial. What is minus b here? Minus of minus 4 by 2 factorial, that is 2. So minus minus cancel, 2 2s are cancel. The limit is how much? 2. If it is x square, the answer is a equal to minus 2, b is equal to minus 4. Limit is the same coefficient value will give limit. So limit is equal to 2. So this is the way to do this problem. Did you understand? This is the way to do the problem. Do you understood? Understood? Yeah. Tejaswini, everyone understood? Everybody understood or not? Everyone understood? So I'll give you one question homework. Okay, this is you understood, na? I'll give one question homework to you. So this is easily understood, right? So I'll give one question homework, so similar to this. So you can do that is homework. The question is like this. F of x is equal to a cos x plus b x sin x minus 5 divided by x power 4. So I write as limit x tending to 0. A cos x plus bx sin x minus 5 by x power 4. If the limit is exist and finite. This they will give for every question. Don't worry. Find a and b values and limit. So this is the question you have. So this you can do homework. Okay, I explained that one. So you do this is homework. Okay, a cos x plus b x sin x minus 5 by x power 4 exists and the limit is exists. Find a and b and limit value. So you have to find a and b and limit value. Okay, this is homework question to you all. Understood? Is this understood? And I think your chemistry class is going to start, correct? Okay, you can join chemistry lecture. Today actually this was become late, my lecture. Okay, fine, you can do this is homework, and we'll see. If I get a time, I'll take it at 4 o'clock today class. Okay, 4 to 5 I'll take the class. Bye, take care.